A single B-2 Spirit bomber costs more than its weight in gold. Literally. At $336 million dollars per aircraft, you could buy 140 Ferraris or fund a small country's military for a year. But here's the thing. When it comes to stealth technology, that price tag isn't just about the plane, it's about engineering invisibility itself. Most people think stealth just means painted black and shaped weird, but the reality is far more complex and expensive. We're talking about materials that cost more per pound than cocaine, manufacturing processes that require clean rooms cleaner than hospital operating theaters, and design tolerances measured in fractions of a millimeter across a 69-foot wingspan. Today, we're breaking down exactly why stealth technology is so astronomically expensive and whether it's actually worth it. Let's get into it. To understand why stealth costs so much, you first need to understand what it's fighting against. Radar. Radar works by sending out radio waves that bounce off objects and return to a receiver. The bigger and flatter the surface, the stronger the return signal. A conventional fighter jet like an F-15 has a radar cross-section, or RCS, of about 25 square meters. That means to radar, it looks like a small truck floating in the sky. The F-22 Raptor, its RCS is roughly 0.0001 square meters. To radar, it looks like a marble. That's a reduction of 250,000 times. Making something vanish from radar isn't about one trick. It's about engineering every single aspect of the aircraft to either absorb, deflect, or scatter electromagnetic waves. And that's where the costs start piling up. The first layer of stealth is shape. Every surface, every angle, every edge is designed using something called faceting, creating flat-angled surfaces that reflect radar energy away from the source rather than back toward it. Look at the F-117 Nighthawk. It looks like it was designed in Minecraft because those harsh angles serve a purpose. Each facet is precisely calculated to bounce radar in controlled directions. No curves, no right angles pointing at threats, no perpendicular surfaces. Modern stealth aircraft use computational design to optimize thousands of surfaces simultaneously. Engineers run electromagnetic simulations that can take weeks on supercomputers, testing billions of scenarios. A single design change to improve aerodynamics might create a radar hotspot that requires weeks of recalculation. This computational design phase alone can cost hundreds of millions before a single piece of metal is cut. But shape alone isn't enough. You need materials that actually absorb radar energy, called radar-absorbent materials, or RAM. These aren't just special paints. We're talking about materials embedded with ferrite compounds, carbon structures, and in some cases, metamaterials engineered at the molecular level. Some RAM coatings contain carbonyl iron particles suspended in specialized polymers. Others use frequency-selective surfaces that work like electrical resonators. The B2's RAM coating is so sensitive that it degrades with moisture exposure and requires climate-controlled hangars. Each mission requires technicians to inspect and repair the coating, a process that can take 120 maintenance hours for every single flight hour. And here's the kicker. These materials can cost $500 to $1,000 per pound. When you're coating an entire aircraft, you're applying tons of this stuff. The material costs alone can run into tens of millions per aircraft. Now, let's talk about actually building these things. Stealth aircraft require manufacturing tolerances that would make a Swiss watchmaker sweat. Panel gaps, the space between sections of the aircraft skin, need to be controlled to within 0.005 inches across the entire airframe. Why? Because even a small gap can create a radar return. The F-35 skin panels are aligned so precisely that they use laser measurement systems during assembly. Any misalignment, and you've created a radar hotspot that compromises the entire aircraft. This requires specialized facilities, tooling that costs hundreds of millions to develop, and workers with extreme specialization. You can't just train someone off the street to build stealth aircraft. It requires years of experience and security clearances. Production rates are also brutally slow. The B-2 production line built just 21 aircraft over 11 years. Here's something most people don't realize. Stealth aircraft can't carry weapons on external hardpoints like conventional fighters. Missiles and bombs hanging off the wings light up on radar like Christmas trees. So everything has to be internal. That means you need massive internal weapons bays with complex door mechanisms that open, release ordnance, and close in seconds, all while maintaining stealth characteristics. The F-22's weapons bay doors are serrated and coated with RAM. They're designed to open for less than 2 seconds during weapons release. The actuators that operate these doors need to be powerful, reliable, and electromagnetically quiet. They can't create electrical signals that radar can detect. Each weapons bay system is essentially a piece of precision machinery built into the airframe. More complexity, more cost, more maintenance. Stealth isn't just about radar, it's also about infrared signature. Jet engines produce enormous amounts of heat, and heat seeking missiles love hot tailpipes. Stealth aircraft use several techniques. The B-2's engines are buried deep in the wing, and their exhausts are flattened and mixed with cool bypass air before exiting. The F-22 uses two D-thrust vectoring nozzles that are lined with heat-resistant RAM and designed to minimize infrared signature from certain angles. These exhaust systems are incredibly complex. They need to manage supersonic airflow, handle 2,000 plus degree exhaust gases, provide thrust vectoring for maneuverability, and do it all while being nearly invisible to infrared sensors. A conventional fighter engine costs about $4 to $8 million. A stealth optimized engine system? Try $20 to $30 million per engine, and most stealth fighters have two of them. Here's where stealth gets really expensive. Maintenance. The F-117 required 650 maintenance hours per flight hour. The B-2, about 120 hours per flight hour. For comparison, an F-16 needs about 20 maintenance hours per flight hour. Why? Because stealth coatings are fragile. Rain can damage RAM. Temperature changes cause coatings to crack. Every panel needs to be precisely realigned after maintenance. Special climate-controlled hangars are required. And you can't just touch up the coating with a spray can. Repairs require specific materials, specific application processes, environmental controls, and days of curing time. Some repairs require the aircraft to be partially disassembled. This maintenance burden means you need more aircraft to maintain the same operational tempo, and you need highly trained specialist maintainers. Both drive costs through the roof. With all these costs, the obvious question is stealth actually worth it? In near-peer conflict against advanced air defenses, absolutely. Stealth provides first-look, first-shot capability. It allows aircraft to penetrate defended airspace that would shred conventional aircraft. A single B-2 can strike targets that would require dozens of conventional bombers and massive support packages of jamming aircraft, fighter escorts, and defense suppression missions. During the opening hours of Desert Storm, F-117s struck 31% of targets on the first day while flying only 2% of sorties. They operated over downtown Baghdad while conventional aircraft had to stay on the periphery. But against less sophisticated adversaries, the cost benefit gets murky. You don't need a $150 million F-35 to fight adversaries without modern air defense systems. This is why the US maintains a mixed fleet. Stealth technology is expensive because it's not one technology. It's thousands of engineering solutions working in concert, from computational design to exotic materials, from precision manufacturing to intensive maintenance. Every aspect is pushing the boundaries of what's possible, and costs aren't coming down. Next generation stealth needs to defeat increasingly sophisticated radars, longer wavelength detection systems, and AI-assisted tracking. The B-21 Raider and 6th generation fighters will likely be even more expensive per unit, but as long as advanced air defenses exist, militaries will pay the premium for invisibility, because in modern warfare, if they can't see you, they can't shoot you, and that capability, true operational invisibility, is worth every billion. If you found this breakdown useful, let me know what system you want analyzed next. Until then, stay tactical.